Hi guys, Matrix here with another video. Before we begin, please smash that like button and enable the notifications. Looking at my extremely low upload rate, YouTube might not put my video on your timeline and you don't want to miss out on those pearls of AI wisdom. And to all those unsubscribed viewers, what are you doing bro? Subscribe already.
Look at this graph.
Alright, enough yammering about my dismal channel performance. Let's jump into the video. What you are seeing as a beautiful mesh of spider web is a simple neural network which only has one job: classify handwritten digits from 0 to 9, and it does that quite well with 97% accuracy. How does it work? You might notice this particular neural network has only two layers which take a teeny tiny image of 32 by 32 pixels as input and gives the probability of each digit as output. So if I give it a handwritten image of 3, it might tell me with 70% probability that it's a 3, or 30% probability it's a 2, and 100% probability that I have bad handwriting. Each unit of this network is something called a dense neuron. Dense because each neuron in a layer receives the output of all neurons from its previous layer. Layers which are not inputs or outputs are known as hidden layers. Hidden because you're not supposed to see them, but I'm showing them to you because I'm a nice guy who cares about your intellectual growth. Just kidding, it's terminology. Each dense neuron in the hidden layer just performs this function, where W is a weightage which is assigned to all inputs of a neuron and B is a single bias term which is added to the weightage. Some inputs might prove more valuable to a neuron than the others and will thus have higher weightage. X is the input being received by the neuron. If you recall that each dense unit receives all input from its previous layer, each neuron in the hidden layer of this network has 1024 weights and one bias term. After this operation, an activation function is applied on the result, which just says that a neuron should fire or not. Here we are using something called a ReLU function or rectified linear unit. It sounds fancy, but basically what it does is simply zeroes out its input if it's negative. If the input is positive, it does nothing. There are 128 neurons in the hidden layer and each neuron has 1024 weights and one bias element. We can combine all the weights of the hidden layer in a 2D matrix of 128 cross 1024 elements and bias as a 1D matrix of 128 elements. The story in the next layer is also similar, except now we only have 10 neurons which denote 10 digits from 0 to 9, and our activation function just tells us the probability of each digit appearing in the input. The weight matrix is thus 128 by 10 and bias matrix has 10 elements. The forward pass of this neural network can be written simply, which most neural network libraries will implement as a sequence of matrix multiplications. Now when the network is untrained, the weight and bias elements are chosen randomly. If you feed the network some input, you will see it classifies it randomly and often incorrectly. It's like rolling a 10-faced dice to predict what the digit in your mind is. The training of these networks happen by repeatedly adjusting the individual weights and bias terms by using something called gradient descent and backpropagation. We'll explore gradient descent and backpropagation in a future video, but for now it suffices to say that weights of the neurons are adjusted in a way so they learn to output desired values over time. In this case, they learn to classify each digit to its correct category. So guys, I hope this was educational and visualization was helpful. I'll see you fine people in the next video.